We're going to see a demonstration of spinning and baking photoresist on a wafer. And our wonderful model here is, or student helper is Bill Clark. When we begin this process, the first thing we have to do is we have to turn on facilities, which are vacuum and nitrogen for the spinner. And then we turn on the power to the spinner. And at this point, we need to make sure that we have adjusted the spin speeds and spin times to be the correct values. And what we're doing, we're going to be spinning 1818 photoresist. The spin that we use is a 3-second spread at 400 RPM and a 30-second spin at 2500 RPM. So it'll do the slow speed spread first to spread the photoresist out on the wafer, and then it will speed up to cast a nice uniform film of photoresist. And the first thing you want to do is make sure you have those spin parameters set correctly. Now we're going to go get our wafer. Just to give a little bit of a frame of reference, here is one of our training wafers before it's had photoresist spun on it. So this is what it looks like before you put it on the spinner and spin resist on it. Even though we're in a clean room and we use a lot of filtering to keep particles out of the air, dust is still our enemy. And so we will, before most steps, dust things off like wafers and masks using nitrogen. And we have a little nitrogen blowgun, and we just take nitrogen and use it to dust off the surface of the wafer before we do something like spin photoresist or place the wafer in a mask aligner. And now we're going to load the wafer onto the wafer chuck on the spinner. This is just kind of a physical skill that you have to develop to be able to do this. And it's a matter of setting the chuck down and turning the wafer on at the right times. And after the wafer has been placed, you turn on the spinner, and if it spins nice and uniformly, well, then you know you're ready to go. If the wafer isn't centered, then when you start spinning, you'll see how the wafer wobbles. That's not good for dispensing photoresist. So it's very important that the wafer be centered properly. So now the wafer has been loaded such that it's nice and centered on the chuck. And at this point, we will dispense photoresist. We'll draw photoresist up out of a jar using a 3 milliliter syringe. So here we're taking the syringe, drawing the resist up out of the jar. Now what we're going to do is we're going to dispense a little bit. Hang on a second, Bill. Let us know when you're ready. We're going to dispense a little bit of resist off to the side till we get a nice continuous flow. Then we're going to go towards the center of the wafer and dispense just about straight up and down. We won't dispense all of the resist, because if we dispense it all, we'll wind up creating bubbles all over the surface of that resist. Once the resist is dispensed, we start the spin. Starts off slowly just to spread the resist, and then speeds up to cast a nice uniform thin film of resist. With this particular spin of 1818 resist at 2500 RPM for 30 seconds, we're expecting a final resist thickness of about 2.4 microns. And there you can see the wafer right after the spin, but before it's been baked. Now that the wafer has been spun with photoresist, we need to bake that photoresist to drive off some of the solvent and to make it essentially a solid instead of a liquid. We're going to do that using a hot plate that's been set to 115 degrees C. And we're going to basically place the wafer on the hot plate. We've got vacuum chucks on this hot plate to hold the wafer down and get a nice uniform bake. And we're going to bake for 1 minute at 115 C. Now the bake is complete. Now that our wafer has been coated with photoresist and baked, we're going to prepare for exposing the wafer in the mask aligner. The first thing we're going to do is we're going to clean our chrome mask that has the pattern that we're going to be putting on the wafer. And what this is it's a piece of glass or quartz that's got a chrome coating that's been patterned to match what we want for this particular processing step. And what's going to happen is this chrome mask, just to make sure it's fairly free of photoresist and so forth from previous runs, we're going to wipe it down with some lightly soaked wipes with acetone. And the way we normally do this is in something like overlapping quadrants that we wipe down. So we'll go over one quadrant here, bearing down pretty hard and dragging the wipe, and we soak the other side of the wipe and do the next quadrant. And we'll flip the mask around and repeat on the other side. This cleaning procedure works pretty well when we've just got routine use of the mask. Once the masks get really dirty, we have a more sophisticated procedure that we have to go through. Most of the time, this is quite adequate for us. And once again, the last thing we want to do just before loading the mask into the mask aligner is dust it off, because even here in the clean room, dust is our enemy. We're now ready to load our mask onto the mask plate of the Carl Seuss. To do this, we first press the change mask button. And that releases the locking mechanism, vacuum locking mechanism that holds the mask plate in place. We take the mask plate out, set it down on the little tabletop. And now we're going to take our mask and we're going to put it on this plate in the correct orientation and chrome side up. We're going to push the mask until it registers with the 3 pins that you'll see delineated here. That locates the mask. And now what's actually going to hold the mask in place is vacuum. There's a vacuum chuck, and we press the enter button to toggle the mask vacuum. And if you look now, if you actually try to push the mask away from those pins, it won't. The vacuum's holding it to the mask plate. That's good. And now, just as a safety, we have a mechanical clip that we can release so that if we happen to lose vacuum, the mask will be held in place. There you go. Okay, now that the safety clamp is in place, we're going to load the mask plate into the Seuss. Now notice this motion here. We've got a hand bridging the mask. Just in case anything goes wrong, the mask isn't going to hit the floor. It will fall into our hand. And now we slide the mask into the tool. Nice